Hi guys, Audrey here. So we know that the test for divergence, TFD, or the midterm test, tells us that a series diverges if the associated sequence does not converge to zero. So if we do the limit of the general term of our series and it doesn't equal zero, then we know that the series diverges. However, if we do the limit and we get that it does equal to zero, that doesn't give us any information whatsoever. Maybe it converges, maybe it diverges. So let's just do a couple questions here where we apply the test for divergence. So we're going to apply the test for divergence to the following series. If the test for divergence fails, in other words, it doesn't tell me if it converges or diverges, we'll just state this. So the first one that we're going to do, we will look at the sum as n equals 1 to infinity of 3n squared minus 6 over 2n squared plus 1. So applying the test for divergence is the same thing as determining whether or not the associated series converges to zero or not. So I'm really just looking at the limit of that inside part. So here we will look at the limit as n approaches infinity of 3n squared minus 6 over 2n squared plus 1. And this is infinity over infinity. We got that n going to infinity, so we can just take the big stuff. Oops. We can take that 3n squared on the top here and that 2n squared on the bottom. And just by looking at this, hopefully we can see that this is equal to 3 over 2. Well, 3 over 2 does not equal to 0. Does not equal to 0. So we can then conclude that this diverges by the test for divergence. Test for divergence. So again, to remind you, what this means is when I'm adding numbers together, I'm adding. When n becomes like extra super huge, the numbers that I'm adding are super close to 3 over 2. So it's almost like I'm doing 3 over 2 plus 3 over 2 plus 3 over 2 plus 3 over 2 forever. And clearly that's going to be infinite. All right. So let's look at another one here. Let's say that I have the sum of n equals 1 to infinity of 1 over natural log of n. So again, here I'll do my limit. I'll do my limit as n approaches infinity of 1 over ln n. Well, we remember that natural log of n, so natural log is approaching infinity. So if I look at a function natural log, remember it looks like that. So the sequence would be like just little dots at the whole numbers. So clearly this is still going to infinity. So this would be like 1 over infinity, which is equal to 0. So when we get really big, it's like we're doing 0 plus 0 plus 0 forever. And so eventually it's like we're not really adding anything. We're not getting significantly bigger. But the question is, did I manage to get to infinity before that happens? I don't know. Maybe so. So in this case, the test for divergence just fails. We'll have to use another technique to determine whether or not this thing converges or diverges. So at this point, all we can say is that the test for divergence fails. All right. So really applying the test for divergence is the same thing that we've been doing when we were determining whether or not sequences converge or diverge. So all of the techniques that we've learned, the squeeze theorem, L'Hopital's rule, the taking the big stuff, the determining which one is bigger, that like sort of graph of how fast things grow. I believe we called it a growth rate chart. Like all of that is still going to be useful right here. It's no different from what we're doing. So then the question becomes, when the TFD fails, when the test for divergence doesn't give us information, what do we do? And we'll answer that in the next video.